Let's see how would you integrate 1 over square root of a quadratic expression. In order to integrate that, we have a special formula in integral which is given by 1 over square root of x square plus a square is nothing but ln of x plus square root of x square plus a square. There are a few special formulas like this in integration. If you want to check out the full list, don't forget to check out the video which is attached on the top right now. That video is one of a kind on the entire YouTube, so don't forget to check it out. Now let's see how would you integrate this one. In order to integrate this, you'll have to simplify this a little bit. So you can write that to 4x square as 2x the whole square. And that 1 can be just written as 1 square. So you can just write it as 1 square plus 2x the whole square with respect to x. Now it is in this form that you are interested in order to apply that formula. So what you can do here is we can just write it as ln of mod of x plus the same thing. So x plus we have the same function over here. So x plus square root of 1 square plus 2x square plus let's add the constant of integration c, and remember that in integral we always have to divide by coefficient of x. In this case the coefficient of x is 2, so when I'm done integrating I have to divide by that coefficient of x. Don't ever forget to divide by coefficient of x once you are done integrating. It is essentially opposite of chain rule in differentiation. In chain rule you would multiply by coefficient of x, but since integral is antiderivative we have to divide by coefficient of x, and this is nothing but your final result. You can simplify this a little bit and say ln of x plus square root of 1 plus 4x square plus constant of integration c, and don't forget that divide by 2, and this is nothing but your final result of that integral. How cool is that? By knowing that special formula you could integrate that difficult looking integral in few seconds. If you understand the concepts that I'm teaching you, can I request you to like this video and subscribe to this channel? It is free for you, but it motivates me to create more such helpful content. I do post math and calculus content every single day, so you don't want to miss it. I'll see you tomorrow.